Hello everyone, welcome back. So now we're going to be doing another problem with couple moments. This time we're going to be using the scalar method to solve for this. Now, what we're trying to do, we're trying to figure out the couple moment caused by these things. And this geometry, it looks kind of crazy. It's much scarier than our previous examples. So you might be like, oh, this is going to be really, really difficult. But honestly, it's not. It really isn't. Because you're going to see quickly that if we break this up into components for each of the forces, that one of those components is going to cancel out. We don't even have to worry about it. So let's figure it out. And let me erase all this on the slide. So what you're going to do, you're going to resolve the forces into their x and y directions, so you can treat them as couples. And you're going to add those two couples because it doesn't matter where they're applied. As long as they're applied on the same object, you can move them around so that they can be overlapping, and you can add them just like a vector. Okay, now right here is the moment where you pause. I give you a couple seconds and you try it on your own, and then you come back after a few minutes and see if you got it right, or see what you need to do to get unstuck. So 3, 2, 1. Okay, you've paused, you've tried it, and now let's work through it together. Sorry, there we go. Okay, so first off, we have two components. Make sure I didn't jump past. I did jump past something. There we go. So first we're going to work on with this 50-pound component right here. What we need to think about though is that this 50 pounds has a component going up and has a component going in the x direction. But think about this. What is the perpendicular distance between the 2 points where these forces connect? It's horizontal. So the horizontal force won't cause a moment if I'm using this distance. Horizontal force won't do a moment at all. So what I need is only the vertical force. So only those 43.3 pound components create a couple. I'm using that 3-foot distance. Now why is that? Just think about it, okay? Force times perpendicular distance. The distance, which has to be perpendicular to that force, is horizontal. So the force component that I use must be vertical. Okay, very similar situation right here. Do both the components cause a force? No, only the horizontal component does in this case, because the distance, that is the perpendicular distance, is going to be vertical in this case. So vertical distance, horizontal force. Horizontal distance, vertical force. And then I just add them together. And I'm done. Now, if you wanted to, you could take a cross product from where these two act, and you get the same exact thing. There's lots of different ways you could have done this, and they would all get the same answer. Just some are easier than others. This is the easy way to realize that if you break it up in the right components, things are going to go well. So make sure you try this in the future. Make sure that you're very careful so that you have your components helping you out. The last thing we need to think about is, well, what direction does this turn? I'll draw a vector. That's my position vector. And this one right here, you can see, okay, it turned me clockwise. I draw a vector from here to here. I follow it, hit my force vector, turn back, and this one turns me counterclockwise. And we see that this one's negative because counterclockwise is always positive. That's the 43.31 coming from here. And this one right here is positive, and that's coming from right here. So, with that, you've solved this problem. Hopefully it makes sense. It goes quickly, but you just have to realize you're breaking things up into components. Your x component and your y component. This one right here is the y, this one's the x, and depending what direction your distance is going, depends on what component you will use for that problem. So, hopefully this helps you. If it doesn't, go back through it a couple times, watch the video again, and I'll see all of you next time. Bye-bye.